I think we're rolling. Get my hat on here. Feel a little more in the zone. So today, what are we doing? Today, we are doing Leetcode Premium. So yesterday's stream, I was doing Leetcode, and a great user by the name of No Condom Chris suggested a few different things, and Leetcode Premium was one of them, basically to make debugging easier. But I said, hey, if I'm going to use Leetcode Premium, let's try out like the various features it has, and one of them is to pick, like for Fang, you can pick vendor specific, and you can do these assessments. So we're going to do one of these. Here's an agenda before we dive in. And by the way, today's stream will be about 2 hours. So it's like 10 till 11 a.m. Eastern right now. And I have a cutoff at 1. I'm meeting with a cool person, do some offline coding. I mean, it's still over the internet. We're just not going to stream it. So coding all day today for me, and I'm stoked about that. Here's a quick agenda of like my next upcoming streams. So today, the Leetcode Premium thing. Next stream, which might be later today or it could be tomorrow, I'll work on the knapsack problem. This is another thing No Condom Chris recommended. Binarysearch.com is another thing he recommended. So I'm going to try that out. That might be Tuesday evening or it might be next weekend. I'm not going to be streaming on Wednesday. And then I may or may not stream Thursday. Probably not, but I might. Depends how the work week is going. And then Google Kickstart was another thing he recommended. Google Kickstart. So I signed up, but I haven't done one. So I'll try to do one of these, as well as the real-time Leetcode competition next Saturday. So practicing the algorithms, gearing up for that bad boy. I've never gotten 3 right. I feel like so I'm trying to break that ceiling. So they give you like 4 problems, and I usually get 1 or 2. Unrelated to algorithms, 2 more streams tomorrow. I'll be working on the Starboy, Rockstar Boy applications. So this guy, kind of adding in some features and making it more useful. So that's not going to be algorithms. That's like React. So tune in for that if you're interested. And then y'all should let me know. I invest in cryptocurrency, and I have some things I need to do. So I can just do that on my own. Or if y'all want me to do a cryptocurrency stream, let me know. So basically, you see right here in my portfolio distribution, it's like 90% Bitcoin right now, and I want to diversify that. And so the tool I use is called HODLBOT. So I can do that diversification. I can stream how I do that if y'all are interested how to learn HODLBOT. And it'll also touch on Kraken and Binance, some exchanges, as well as Coinbase. So if you're interested in that kind of thing, hit me up, and then here I'll leave you with a cliffhanger, give you some suspense and motivate you. You can, if I do the stream, I'll tell you about the one coin I blacklisted. I'm a big fan of indexes. Let the market decide what's right. But and I'm not a big fan of picking winners and losers, but I made an exception for this one coin. And I can explain to you why I did that if we go forward with the cryptocurrency stream. Okay, so there's your juicy cliffhanger. I'm going to say hey in the chat. Make sure y'all can all see me. And I'll open up off screen. I'm going to open up a Facebook tab because with Facebook, I don't get the real-time chat notifications. So I have to like actually have Facebook open over there. I got 2 monitors set up going. And then we're going to dive in because I don't have much time to waste. So it's about 3 till 11. Cool. Yeah, and I was going to go for the 2 hours, but hey, if I give myself a head start by 3 minutes, I don't think that's like going to break. I don't think that's a game-breaking advantage. Okay, so let's dive in. 4 questions, 2 hours to complete. So it's going to stop me on 2 hours anyway. You cannot pause the timer. Ah, let's go. I have no expectation of acing this, just so you know. But we will fumble together, and hopefully that'll inspire you. Okay. You're given an array of prices, where the index I of prices is the price of a given stock on the ith day. You want to maximize profit by choosing a single day to buy stock and choosing a different day to sell stock. So I can only do one, or can I do this repeated? Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Buy on day 2, sell on day 5. Cool. So you can only do one transaction, if I understand correctly. So something that comes to mind here is, what is it, Cadence algorithm? Yeah, Cadence algorithm, which would be the maximum sum. That's different though, because that would be as many as you want, buy and sell. So this is just the one. So you want to buy low, sell high, yeah? So I could scan for the lowest and the highest. That'd be like an edge case. Edge case, highest after lowest. Buy lowest, sell highest. So that's an edge case, but that would be that's not going to be a general solution, because like the highest might precede the lowest, right? Or there might be a tie for lowest, for example. So I feel like I've seen this at some point in the past, but I can't recall how to solve it. Okay, so I'm just going to look at the deltas. I'm going to look at like the marginal profit, right? So 7.1 is a decrease, so I don't want to buy. 1.5 is an increase, so that would be my like best so far. 5.3, no. 3.6, no. Okay, so maybe a best so far strategy. Okay, and would this solve the edge case as well? So highest after lowest. Yeah. There's a problem here. So my best so far strategy, I'm only doing a 1 index look ahead. And the problem is profit could drop then max in indices later. So like here, the best so far would give me 4. But really, the best would be 1 to 6. So what I want to do, this will be increasing my time complexity. So it might not be optimal from a time complexity standpoint, but a better strategy for the robustness of my solution would be, like for correctness, would be, don't just look at the next one. Look at like, look ahead 1 to n. Look ahead 1 to n. Strategy. Okay, that's my new best. So this would be n squared time complexity, because for n elements, see, and that's not quite right. It's not quite n squared, because as I go along, the combinations is decreasing. So it would be n squared maximum, but I think lower. Because like by the time I get to 6, I've only got 2 to look at, 6 and 4. So it's almost like it's n by something else. I don't know. Is it a log? I don't know. It's not a log because we're not dividing by 2. Anyway, I think in the maximum limit it's n squared, but and it's not simply n. So it's somewhere between n and n squared. between n and n squared, but not a log. So I'm going to just attribute it to n squared. It might actually be lower than that. Okay. The thing is like when you're doing asymptotic analysis, it could be lower than that by a fixed number. It could be like 0.5n, but it's or like 0.5n squared, but it's still in the order of n squared. And so that's why I'm going to go ahead and attribute it to the order of n squared, because it could be lower, but I don't believe it's lower by something that would change the order of it, right? I think it's just lower by maybe like a constant multiplier or something. I don't know. Could be wrong about that. And then space complexity, what would I be storing? I would be storing just constants, I think. Like my current best index and my current best value. Yeah, so it'd be constant space. O of 1. So it's pretty, I don't know. Seems fairly efficient. Could be optimized, but I'm trying to think through a complete solution before I think through any optimizations. But it's not like it's like a terrifying red flag of like exponential time or factorial time or something. So I think this is going to work. Right? When I get to 1, I don't need to like recheck 7 and stuff. So I just need to check my forward. And if I go from 7 to 1, it's then I know I'm better off buying at the 1. But depending on what comes before, I might be better off selling at the 7. Okay. So let's start doing this. So I'm going to store let I think I can do like a meta max and then a cur max kind of pattern. That's like a Cadence kind of thing. Almost like a one-dimensional islands, like group, group, group. And you look at like your current group, and then you look at like the best group you've seen so far. So I'm going to go for that flavor of an algorithm. So MetaMax would be like the best that I've done like ever. And then CurMax will be like the best that I've done starting here. So there'd be cur start, cur end. So these are a few of my favorite things. And then eventually we'll return meta. I just returned the return the maximum profit you can achieve from this transaction. Yep, so that'll be my meta max. Okay. So let me do a naive Cadence algorithm, and it's not going to be right, but it will get the general structure here. So I can do a for loop here, and another way to do this instead of iterative would be recursive. That's always good to think about. But I don't, okay, I'll just put it to do. To do, would recursive be better? Like, at first glance, I don't think recursive would be more efficient. And I don't think it would be, like, intellectually easier either. But so a while loop would be really conducive to recursion, where this iterative approach, you could do it with a while loop or a for loop, but arguably the for loop would be more explicit because the termination criteria and the iteration criteria are both clearly defined in the for loop signature, whereas with the while loop, the termination criteria is clearly defined, but how do you get to that termination is defined in the body of the loop. And so it's like you're mixing different kinds of logic within the body of the loop. So you kind of have to like look through and parse it out. So there's a little more cognitive overhead. Okay, so there is our for loop signature. So we're gonna loop through all the prices, and then meta max. Let's say cur max is math.max. So we're gonna initialize these to the worst possible, which would be negative infinity, and that way I can use this max operation. cur start would, we're gonna start with 0, but like it's almost a waste. It's almost a waste of a line of code because it's immediately gonna get reset within the loop. Okay. If you cannot achieve any profit, okay. So return MetaMax is less than 0. Then return 0. Otherwise, return MetaMax. MetaMax. Cool. So the cur max is the max of cur max and whatever I can sell it for. So, yeah. So there's no way it could actually be less than 0 because I could just buy it. I guess I can't, yeah, a different day in the future. You can't buy it and sell it on the same day. That's the trick there. Because I was going to say, like, theoretically, it couldn't be less than 0 because you could just buy it and sell it on the same day. They say buy one stock and choose a different day in the future to sell it. They say that, but from a computational perspective, since the minimum is 0, that's equivalent to buying and selling the same day anyway. So I think I can model it. Possibly could compute as if can buy and sell same day. So I know that's their business rule, but like from a computational perspective, I think we can treat it as if. Because it just nets out to 0. Which would make these initializations at negative infinity, that would make that incorrect. Yeah, I'll go ahead and initialize them to 0. So we just return MetaMax. Right, because if it never, because that's going to be a max operation. Look, it's just like this. Math. This one's actually easier to write because it's either MetaMax or curmax. And so the lowest it can ever be is 0. So we don't need to check if it's less than 0. Only curmax could potentially get less than 0. So with curmax, what we're going to do is suppose that we buy today, and then suppose that we sell at any day. Right. Curmax. So before I do the curmax, I'm going to do const cur price, cur by price equals prices I. And then curmax is already 0. So curmax is actually going to go within an inner loop. And so this is the n squared portion. So for, I think we're on the right track here, my peoples. Friends. So I'm going to try and turn it up a little bit of speed because the later ones are going to be hard, but I'm going to also like try to keep talking through it. So this will be a j. Let j equal I. We're going to initialize j to I. We're not going to loop through all the numbers. We're only going to loop through the remaining numbers. And then this is where I'm going to do my trick where I do check same day. And then like to do maybe j equals I plus 1 if we avoid strategy from above line. Okay? So I'm going to initialize it to I, which means that I'm going to say that the cur sell price could potentially be the same as the cur buy price, and not just because it's coincidentally on 2 different days that they have the same price, but in fact buying and selling same day. Even though they explicitly tell me in the prompt not to do that, in the real world I would not do that. This is just a computational model that would represent I never bought. It would represent the case of I never bought. So buying and selling the same day from a computational perspective is a computational representation of the real world activity of don't buy. And so in that case, there would be 0. So I'm fine with it as a programmer, even though the business rule is don't do that. But if we run into hot water, I got the to-do there. cur sell price equals prices j, the j index of prices. Okay, so j is less than prices dot length j plus plus. Okay, got the matcha kicking right here. I wish I had more. It's good stuff. So yeah, cur max is going to be math.max, right, and I will need to at every buy price, I will need to reset cur max equals 0. This is going to be like day 1, 2, 3. The base case max is 0. I need to separate the concern of the cur max, which is, hey, I'm buying today. When's the best that I can get if I sell? I need to separate that concern of the cur max from the meta max, which is going to go across days. And so that's why we reset it to 0 every time. Okay, but given that it started at 0, cur max is going to be math.max of cur max and buy price minus sell price. Cur buy price minus cur buy price minus cur sell price. Okay, and then we just keep updating MetaMax. Let's see. What did I do wrong, baby? Here's the output. What was the expected output? 715364. 715364. So this is the initial test case, and the output is 5 because they buy on day 2, 0, 1, 2. Okay, so they're starting, this is day 1. So they buy on day 2, and they sell on day 5. 1, 2, 3, 4, 5. Yep. Okay, I'm expecting the same. Okay, so why did that not work? Cur buy price minus cur sell price. I think I might need to do some logging. How would it get that high? MetaMax is MetaMax or cur max? Cur max, they're saying that cur max is 6. The only way I see 6 happening is if you buy at 1 and sell at 7. Buy at 1 and sell at 7 should not be allowed. Buy at 1 and sell at 7 should not be allowed. So what I'm going to do is, for debugging, I'm going to introduce these. So this is cur start, cur end. For debugging, I'm going to record those. So if MetaMax is less than cur max, we're going to console.log. I guess we can just log the indices now, huh? I, J. J is not in scope. So we'll just do I, MetaMax, cur max. So I0, cur max is 6. So I0 MetaMax is less than cur max with I0. So with I0, okay, maybe this logic is just backwards. It's saying that I can buy at 7 and sell at 1 and earn 6. Sheesh! Wouldn't that be nice? Wouldn't that be nice? Yeah, okay. I had my buy and sell price backwards. Awkward! Cool. Now I want to submit it. Yeah, so I think that standard out was missing when I didn't have premium, if I'm not mistaken. And that's super convenient. If you saw the last stream, I had to like open up DevTools, copy my function, paste it over there. It worked. It was just super, super inconvenient. Okay, so this is time limit exceeded. Dang. Whoa, that's a big test case. Shish kebab. Shish kebab. Let's see. So it's not like the algorithm failed because it's incorrect. I almost don't care. I almost don't care about this. Because in an interview setting, if I got the algorithm right, I feel really good. But yo, why is it slow? Cur start, cur end. Don't need you guys. Okay, so maybe recursion is going to be faster. So let's think about that more seriously now. Or if there's a dynamic programming pattern. So in the dynamic programming pattern, the way this would work is it's almost like you start by knowing the answer and then but you don't know the inputs, and then you check prior. It's kind of like a backward iteration. It's kind of like a recursion. So I would be building up. So I could do a build up of all of these guys. Okay, so there's a way this might work. So if I know that I've already tested 7, 7's going to be a bad example because it's the highest. But let's say I know that I've already tested starting with 5, and I know that I've checked 5 to n and I never have a winner. Then there's no way that 6 to n is going to be a winner, right? You dig? So this will be, so I could do it like a scene map, or I could do a max price scene, which is not a hash map. It's just I've checked. This is the biggest. It's like a threshold cutoff. If you're over this, I'm not going to bother about you. So here I would get to skip the 6, and I would get to skip the 4, right? Because by the time I got to 6, I've already done 5. By the time I've got to 4, I've already done 3. Frankly, by the time I've got to 1, I can skip like the rest of these. So it's more like min price scene. So we're going to initialize that to infinity. And then this will be faster. Okay. It doesn't change the time. It doesn't actually change the asymptotic analysis, because in the worst case, they're all the same number. But I guess you could have like a special handler for that. Yeah, that would just be O of n. So maybe we can get to O of n somehow. It's not super clear to me, but yeah, going O of n squared to O of n would be an improvement. Okay, so min price scene equals math.min of min price scene, and this will be the buy price is what I'm referring to. It's like min buy price scene. Okay, and then cur price is prices, and then we're going to say if some condition, then continue. Okay, and the condition is if min price seen is less than or equal to cur buy price, we don't need to worry about it. We already know. Did not harm our output. That's a success, babe. That is a success. How are we doing on time? Was that under 20 minutes? 30 minutes, boo. Well, I did some intro stuff, so maybe that was 20 minutes-ish. 25. I got, okay. I already submitted it. What do I do now? I go to question 2. Are you serious? I thought I had 4 questions. Bro, I got 3 questions? I might actually get through this. Let's not get too hype. Calm it back down. Sorry. You're given an array of... Yeah, these are different questions, right? Oh, at most 2 transactions? This is like way harder, right? Oh, crap. Okay, I'm going to start by copying this. Okay. Yeah, I think it's just like with the analysis, I think it's just, I don't think it changes the asymptotic order analysis like the worst case. I think it changes the average case. So I actually have not done a lot of average case analysis. But basically, I think this solution is O of n squared asymptotic in the worst case, but I think it's like I think it's in the order of O and of n in the average case. I'm really not sure about that. If y'all know, like, can you, here, I'll take a little snippet of this and like leave it on the left. It's the same function because I haven't tweaked anything yet. So I just kind of cleaned up the code. So I'm going to take a snippet of this and like leave it below. And if you can see the, time complexity of that. I think it's O of n squared in the worst case, but I think it might be O of n in the average case. So if you can tell me that, that would be great while I read this problem. No stress. If you don't want to, no problem. So, okay, so you're given an array of prices. Find the maximum profit, 2 transactions. You may not engage. What language is this? This is TypeScript. So it's just JavaScript, but there are types. Like, I know that these are numbers. It's guaranteed to be numbers, the input and the output. So this input is an array of numbers. That's what those little brackets mean. And then the whole function has a colon number, which means the whole function returns number. It's just JavaScript plus types. It's TypeScript. And I think that's Trisha. What's up? Good to see ya. Okay, so let's work on this. May not engage in multiple transactions simultaneously. You must sell the stock before you buy again. Okay. So my naive thought here is that this is just the prior problem plus another loop. Let me write that down. Okay. So maybe a better thought is there's a dynamic programming way to do this where I went and I got the max profit on every day. It's the same thought. So I just loop again, except when I loop the second time, I can tap my cache of max profit with 1 transaction. So on second thought, I think above is correct, but maybe DP is better than iteration, or maybe a recursive approach. So I'm gonna have 2 functions here. So my first function is max profit with 1 transaction. Okay, so max profit. So first I'm going to get days. Const max with one transaction per day, or by day. Max profit for each, max profit by day, one transaction. Cool. And that's going to be an array. So that's going to equal max profit with one transaction. I'm going to pass in prices. Basically, I'm doing the same pattern, inner and outer loop. Okay? So max profit with one transaction. Max profit by day, one transaction. So the difference here is that I don't want to return MetaMax. I kind of do. So here I want to return the index of MetaMax. And I also want to return the whole array. So this will be const each day, or like cur max by day. Okay. Cur max right here, cur max by day, push cur max. Okay, so for each day, we know cur max by day. And then I don't want, yeah, so I do, so this is going to be the MetaMax. By day. Cur max by day, MetaMax by day, one transaction. Okay. So my thought here, I want to take a second before I proceed. My thought is find the day where my one transaction max, yeah, and find the best second transaction. My issue with this is this might not give me the true result. It feels like a little too greedy. So let's say I have like this solution, right? And so the max for one day would be 0, 4. There's like no second transaction after that that I can do, you know? I could just like do it again. I could go 0, 4 and like do it again and look at this subarray and get the best in this subarray and the best in this subarray. Maybe that's the right thing to do. So basically you're looping through to see what the max is, then making another variable to hold the second max. Exactly. So I'm not actually sure that this is the right strategy, but that is what I'm doing. Yeah, we can do this cheat that's not really helpful, but could return 0 early if prices.length is 1. And some other edge cases. If the length is between 0 and 3, there's like some early exit logic that I can do. But if the length is between 0 and 3, I'm not actually worried about exiting early because it's not going to be that long. So I think the naive thing to do is this subarrays idea. So here's const subarrays. So max meta max by day 1 transaction. So I need to know the indices. So here's the meta max. Meta start, meta end. I can determine that. I can determine that externally. So here's going to be let meta start, let meta end. And what I want to do is get the smallest subarray. Get smallest subarray that allows that. Because it could be the case that there's like 2 ways to do this, right? So here, that 0 to 4 gives me 4, and that 0 to 4 gives me 4. I want to take the inner subarray because that will increase the search space where I could maximize profit for a second transaction. Now, the other trick is that this only has 2 subarrays, but there could be another one over here. There could be like 3 subarray situation. Okay. Max profit with 1 transaction prices. Great. So the meta start and the meta end. So this can be faster if I can at least return the min and max buy price. Min and max buy price. So let I'm going to call it memo buy price because we're like caching it. So memo buy price, memo sell price. I guess I can just, yeah, I don't want to memoize the indices because I want to find the narrower indices, but I do want to memoize the prices because that will basically speed up my search. So memoize buy price. So if math.max, so if curmax, if I can make more profit, if curmax is greater than metamax, then metamax is equal to curmax, and memo buy price is equal to, and we'll default memo buy price to 0, which means, can you buy it for free? That's crazy that you could buy it for free. We'll do it. I might need to do like a -1 kind of thing there, like I never bought it. But they're saying you really can buy it for free, which is kind of counterintuitive to me. Okay. Curmax is greater than metamax. So then that's our new most profit that we can get. And the buy price, we're going to cache it cur buy price. Okay. So now I'm going to return memo buy price, memo sell price. Just break this up a little. So this will be memo buy price, memo sell price. I'm going to use this 1tx for 1 transaction. So, right, cool. And this will be meta start, meta end. Yeah, that's all correct. So the memo sell price is what I need to figure out now. So I need a, if the curmax is greater than the metamax, yeah, I need like a temporary, cur sell price. Here's cur sell price. And then this would be the let cur best sell price equals 0. I think I'm gonna go for -1 there. -1 means never bought. Okay, cur best sell price. So if that improved my profit, then the cur best sell price is cur sell price. So this will be if buying and selling with this combination increases my profit on this buy price. Okay, cur sell price, cur buy price. So we're going to set cur max is this buy sell combination. Okay. And now we know the cur best sell price. So that's the cur best sell price. And then we only memoize the cur best sell price if this buy price is the right one. Memo buy price, memo sell price. Okay, so memo buy price, memo sell price. Great. Got him. Got him. So now find the day where my one transaction max. Great. So we're gonna get. There's gonna be multiple indices. I want to get smallest subarray. That's that's a different helper. Function get smallest subarray, and this will take haystack. I'll call it. That's the bigger array, and then we'll have start end. Okay. So this will return. I'm going to any these returns, otherwise it'll compile fail. So it'll return any, but what it really, in a real application you wouldn't type it any, but I just don't want to type this. I don't want to spend the time to type it, but basically what it's going to return will return start end for indices for smallest. What's up?
Want to play with the Ellie toy?
Nope. Love you.
He saw me and Daddy on The Little Mermaid. And he says, I love my daddy. I need my daddy. And I said,
Aww.
okay.
Are you watching The Little Mermaid?
Uh-huh.
That's a bad guy over there.
All right, baby, come on.
I need a napkin.
All right, take one tissue.
Have a good time.
Thank you, baby.
Bye-bye. Can you bring me a drink of any kind?
Yes.
Thank you.
Cold or...
Yeah. Okay, so we're going to get the smallest subarray. And let me just pseudocode this out. So get smallest subarray. Check max profit in remainder subarrays. And then sum the two highest of 3 subarrays of up to subarrays profits. Okay, so that's my strategy going forward. Cool. So so here we're going to do const narrowest, start narrowest end equals get smallest subarray of haystack. Where's haystack? Haystack is prices in this case, prices. And start, and this will be start and end value. Start value, end value. Okay. So then I will have const subarrays equals this is going to be kind of const subarrays equals get subarrays. It's going to be kind of hacky, so I don't want to do that. Thank you. I'm going to split that out so I can keep my main function clean. I'm also going to take the comment above the method, keep it all clean. And I'll just have the one comment to do sum max profit for top 2 subarrays. Then we'll not return metamax, so this will be const profit of 2 best transactions. And I have to be honest, I'm not actually sure that this will yield me a correct solution. Like everything I'm doing right here, like I might have like the implementation wrong, basically. I'll just zero that for now. Cool. So here's the main function. Get subarrays. Prices. So first split and second split. Okay. So if first split is 0, if first split equals 0 or second split equals prices.length, then only 2 subarrays. Okay. Otherwise, three subarrays. And I'm actually not sure this is true, because what if there's a 1 here? Then it wouldn't be possible for me to buy and then sell. Ooh, oh. See you, Trisha. Bye. There's actually a crazy idea here that I didn't think about earlier, which is Oh no, this is right, because I can only hold one at a time. I was thinking, what if they bought in the first subarray and sold in the second subarray? That's disallowed by our business rules. Oh. I'm sorry I didn't see your message in time. What is this? I think this is orange juice and sparkling water. I was like, is this a kombucha? I didn't think we had kombucha. Okay. So I don't need to worry that they're going to buy in the first subarray and sell in the second. So they're going to buy in the first subarray and sell in the first subarray. But if there's only one index there, they can't do that according to our business rules. So I could just skip it. But my function can handle buying and selling same day. But it'd be better from a computational standpoint just to skip it. So if the first split is 0 or 1. So if the first split is less than 2. If it's 0 or 1, then there's only going to be 2 subarrays. If the second split is greater than prices.length minus 2, I think. So let's go on this example and say that the 5 is the only remainder. So it'd be 0, 1, 2, 3. Index would be 4. 0, 1, 2, 3, 4. If the 4 is the second split, even if the 3 is the second split, which means it's the end of my inner subarray. Yeah, so it's minus 2. 1, 2, 3, 4, 5, minus 2. Okay, there's only 2 subarrays, else there's 3 subarrays. Okay, and then the first subarray is first split, second split. Subarrays dot push first subarray. Okay, so that's the first subarray, and then this. So in this top case, there's only 2 subarrays. So I need to check: is it an end subarray or a beginning subarray? So I'm actually going to split these 2 cases. So if the first subarray is less than 2, only 2 subarrays. Second sub is a late subarray. There is actually a case. Yeah, there is actually a case where there's only 1 subarray because both of the ends are squeezed, and in that case, the total best of 2 transactions would be the total best of 1 transaction. So if subarrays.length is just 1, return meta max 1 transaction. Yeah. What's this cur max by day thing? Oh, that's the whole array. Yeah. Okay. Meta max 1 transaction. Cool. Okay, so if there's only 1, that's it. And if there's 2, yeah, we're going to do the summing later. Cool. Get smallest subarray. We're doing. I'm pushing that down the road because that is hard for me to think through right now. Well, let's say that I have my indices, then I have the first subarray, the second subarray is a late subarray. Second subarray is a late subarray. Yep. And then else if the second split is if the second split is too small, then there's only two subarrays. Second subarray is an early subarray. Yeah, I actually need to test both. So const has late subarray is this condition. And I don't need the comments anymore because that variable makes it pretty clear. So if it has a late subarray, that's actually not a correct name. It's going to be has late squeeze is what I'll call it. Has early squeeze. Squeeze means the subarray is too small to allow buying and selling on different days, e.g. length is less than 2. Okay, so if it has a late squeeze and if it has if it has an early squeeze. I got that backwards, didn't I? Yeah, if the first split is less than 2, then it has an early squeeze. Okay, great. So if it has both, we actually need to check if it has both. So if it has both, then we just return subarrays. There's only one. There's only the one. Otherwise, if it has an early squeeze, otherwise if it has a late squeeze, and then the case where it has neither, there's 3 subarrays. Okay. So what if it has an early squeeze? That means that it has a late subarray. Okay. So const second sub start equals it's going to be the second split plus 1, right? And then second. So I can actually just do this more quickly, which is going to be subarrays.push this new array, which is second split plus 1, and prices.length minus 1. Right? Taking a second to double check that, but basically if it has an early squeeze, then the only additional subarray is the late subarray. The late subarray will start, so the day that you sell, can you buy the same day? Why even would you? That would net you out 0, and so you shouldn't even sell in that case. So the answer is, even if you can, you shouldn't, from an optimization point of view, so we can ignore the case. I think that's correct. That's like halfway thought through, but I think that's correct. Second split plus 1, and then all the way to the end. The end of the array is the length minus 1. Yep. Okay, and then if it has a late squeeze, it has an early subarray. So that will end first split minus 1. And it will begin at 0. That's the search space for the early subarray. And then you could do both over here. Has 3 subarrays, second split plus 1. Could dry this code a bit. I'm not going to though. Like in real world and in my code base, I would clean that up, but this is like an algorithm thing, so I'm hurrying through. Okay, I think this gets us our subarrays. Okay. So I only need to return find the maximum profit you can achieve. So I only need to return the profit. So if the subarrays.length is 1, return the max there. Cool. So here is subarrays. Second subarray. So this will be second subarray max profit equals so subarrays 1, and then if subarrays.length is 2, 1, 2, 3. If it's 3, then we need to consider the third subarray. And so in that case, we will do so we're going to say let third subarray profit equals 0, and then if this is a thing, then this is like some terrible naming. Actual third subarray profit is going to equal to this, and then this third subarray profit is going to equal to the actual third subarray profit. Okay, so and then here, so the then we're going to have const other or like best. So this is second subarray max profit, and this is best second transaction profit equals math.max of second subarray max profit and third subarray max profit. Okay, so the best second transaction profit is whichever is bigger, the second subarray max profit or the third subarray max profit. And then return return the best profit for 2 transactions. So this is my idea. Again, I'm not actually sure this is correct. We need to implement this method, and then we can start testing it and running it. Okay. Get the smallest subarray. Get the smallest subarray. Start value. So I'll have const starts is an array, const ends is an array. I think I need to do a 2 loop. This is like, I don't know if this is optimal, but I think it'll work. For each start, get closest end. So this will be like start end pairs with length, and then return start, and then like loop through lengths and return start end pair. So we got best start and best end. Okay. So I have all these places I could start and all these places I could end. All these places I could start, that'll all have this starting value that I'm looking for, and all these places that I could end. Start and end value could also both be -1. Okay, I need to handle the case buy memo price, sell memo price. They just note they should never concurrently be -1. I'm sorry, they either both should be or they both shouldn't be. You should never have, there should never be just one memoed -1. Should have 0 or 2. Okay, that's just a note in case we end up debugging that that's a situation that should never happen. Okay. So I'm only going to check, and then I'm going to ref that note. I'm going to refer to that note because if I do end up debugging, it might look like there's a problem here, but really there's a problem earlier way back here. And so handle case where either is -1. So if either start value or end value is -1, what that means is the optimal situation is not to buy at all. I really want to handle that outside of this scope. Get smallest subarray. Yeah, if the best transaction for the whole thing is not to buy at all, I don't need to. Why are you doing Leetcode? Do you have interviews soon? No comment. My audience cares a lot about algorithms, though. Hey, shout out to Frog Fan ACC. It's not Austin Community College, is it? Quick note, since you're watching, if you do the TikToks, follow me on TikTok. I'm trying to grow my audience on TikTok so that I can stream over there. So I teach people how to code, basically. It's short for account. Okay. Frog fan account. Got it. So I teach people how to code and get jobs as a programmer. So I'm a professional programmer. Love helping people. And if I can stream on TikTok, I can help more people. A bunch of people are over there watching my short videos, but you get a much bigger audience if you can stream. Here's my handle. I'll show you if you're curious. That's me. Secure an internship my summer after sophomore year. Cool. Yeah, download it. Follow me. You can also hit me up on Twitter or LinkedIn. So my Twitter handle is the same. I know there's like a capitalization difference, but Twitter doesn't care. If you do it all downcase, it'll still bring you here. So the downcase is the same handle on Twitter and TikTok. My Twitter mentions my TikTok. And then here's my LinkedIn, John-Vandeveer. So I know I'm flying through that kind of quick because I'm on a timed assessment, but you can rewatch the stream and go check it out. Yeah, link up with me. Getting you an internship is like not a problem. So let's just talk about it after the stream. Okay. Get smallest subarray. Right. So if either of them is -1, then the solution to the whole max profit problem is just 0. So if subarrays.length is 1, so I'm going to if return 0. If metamax for one transaction is 0, then the solution to the whole problem is 0. Okay, so now we know that there is some profit to be made. And so if there is some profit to be made, at this time, first split and second split should both be greater than -1. And second split should be greater than 0. But first split can be 0. That's fine. Okay, so yeah, first split and second split should both be -1. Thanks. And then also here, start value and end value should both be -1. Yeah, what brand is this? I got it at Walmart. It's Turtle Beach. Let's see if you can see this. Yeah, you can see that, right? It just says Turtle Beach. It works really well. And it's not like, I don't know what, if I recall correctly, although it's been a minute, but if I recall correctly, it's not expensive. Okay. Get smallest subarray, and they're going to be, I don't have to worry about the -1 thing. Handle case where either is -1. I don't have to worry about that anymore. Okay. Start and end pairs plus length. Yep. So this will be lengths. Lengths is going to be a hash map. And here's a trick. Here's a correctness issue. Could have multiple smallest subarray lengths. Could have multiple smallest subarray lengths at different locations. That would be a real pain in the ass. I'm just gonna like ignore that for now, but I shouldn't ignore that. That's like a real problem. I'm gonna put that in caps. Correctness issue. I'd like to think that if you have a generous interviewer and if you get to this step, they're gonna like, even if they don't give you full points, they're gonna give you pretty damn good points, because you got to be deep down the right path to even run into this issue, right? Leetcode is merciless though. Like, I'm pretty sure Leetcode is going to fry me on that. So I might jump over to question 3. Because we're at 44 minutes now, and I've been on this one for 45 minutes. Okay, but let's get through the implementation. So get smallest subarray. I just got to loop through all of them. For const L of haystack. And I know these elements are integers, so I'll make it I. For const I of haystack, if I is equal to start value, if I is equal to start value, else if it's equal to end value. So if it's equal to start value, starts dot push I, and if it's equal to end value, ends dot push I. Okay, so now I have my starts and my ends, and I need to compute lengths. Okay, so for each start, there should always be at least one starts element, and starts and ends member. That's like a debug note. If that is not the case, we have a problem. Oh, thanks for the likes. That's awesome. Love that support. Love that support. Okay. There should always be at least one start and ends member. So we're going to say for const start of starts. And I have to do this. It makes me cry. This is why I kept kicking the can down the road. But I have to do an inner loop. Const end of ends. I have to do an inner loop. It's so gross. So this will be lengths of equals start end. And really, like, this is where this note should go, because really I should be handling multiple cases. Get smallest subarray. Let me put that note down there. To do correctness issue can have multiple smallest subarray lengths at different locations. If I was running low on time in an interview, I would literally tell the interviewer, I would like kick the can down the road. And I'd be like, let's get to the working solution, even if it's not optimal or even if it doesn't handle this edge case. Do they really have you do long questions like this for technically? Only at FANG companies, at tier 1 companies, Facebook, Apple, they really do. At these tier 1 companies, but at tier 2, 3 no-name companies, you don't do this unless they're like wannabes and they're trying to act like FANG. So for 90% of the 95% of the industry, this is not necessary. But yeah, for 95% of the industry, Leetcode is not necessary. But it's like the really prestigious top tier that everyone wants to get into. They really do. They really do this. And that's why it gets so much attention, because it's like most of them have live coding part of their process, right? Yeah, all of them. Yeah. It's not even Fortune 500, man. It's like Fortune 50. Fortune 50 will be doing this. You can get a Fortune 500 internship without algorithms, for sure. Like SAIC is in the Fortune 500, right? Rank 412. You can get a job at SAIC without... What? This is SAIC Motor Company? Yeah, word. Shoot as high as you can. Yeah, my advice to people is like, if you want to program, learn how to program, and get good at coding. And I would say don't prioritize algorithms, but I know other people say differently, so whatever. My thing is like, get your job as a coder and learn algorithms after. But then you could be adding years. If you're like super smart, you could just go straight to Google. And so it's like, why am I wasting like 4 years? So I get that, but that's not true for most people. It kind of depends on like who you are. And the problem is a lot of people think they're way cooler than they really are. You know what I mean? Like a lot of people think they're fucking elite. Like, bro, I have a PhD and I'm still not, I don't think I'm elite enough to just go straight there. Okay. Where was my train of thought? All my friends are talking about Fang, Capital One, unicorn startups. Capital One is not that hard. Like, I worked at Capital One. Did you see that on my LinkedIn? Capital One's not that hard to get into. So I went in as a senior, and they did give me an algorithm interview, but it was like the easiest algorithm interview I've ever had. It was like, I literally got the fizz buzz question. So I was working at Capital One recently. Yeah, I mean, yeah. If you want, yeah, as a senior, they gave me fizz buzz because I feel like they got that pressure. Don't stress about live coding. You know my philosophy on live coding? This might not be, yeah, okay. This might not be what you want to hear, but my advice is just go in assuming that you're going to flunk. And then you don't care. And then it turns it into a positive experience. Because at that point, you're like, I'm assuming that I'm going to flunk, but at least it's practice. At least I can get better. There is a chance that I pass, even though I'm not assuming that, but maybe I could have this nice surprise. And you also get like a social networking opportunity because literally your interviewers, if you're having a panic attack, you're going to like freak them out, right? But if you're just like, hey, like it's nice to meet you, and you really make it like it really is nice to meet you and network with you, that's like valuable even if that's all that happens. Exactly. Nowhere to go except up. Like I back in the day I had a Twitter interview and I got to a solution, but it wasn't optimal, and so they did fail me. But I had a really great convo with the guy who was interviewing me, and he's like my friend now. So it was still really chill. And that sort of thing brings you opportunities. A bunch of the people I worked with at Capital One, they now work at other Fang places, and so never know where opportunity is going to come from. I need to actually solve this problem. Okay, lengths. And this is the correctness issue that I'm worried about. I put the note there. So now that I put the note there, I can move on for the time being. That's one of my advice is you're going to have like 1,000 thoughts. Write the thought and move on. Don't dwell on the thoughts and don't try to keep track of them in your head. So if you write out the issue, then you can go back to what you were doing and ride that thought train, baby. Ride that thought train. Okay. Yeah, so if y'all are watching and you're not on Twitch, there's like a really great convo going on Twitch. So I think you're missing out. Got people tuning in. Let's see. LinkedIn, Facebook, YouTube, Twitch. So Frog fan account just basically said someone told him they don't care as much whether you pass, except can you stay calm, your ability to communicate, and explain your basically your approach, notice any mistakes that you made, and then they also do care about your debugging skills. That's all true, and it depends on your level. So I think you were talking about getting an internship. I have never been an interviewer at Facebook. Don't want to misrepresent this. I could probably get you a phone call if you just want to have an informational talk with some people at Facebook. But I suspect that for an internship level, like I would be absolutely floored if they gave you like this and anything like this at an internship level. I think question 1 that I did, I could see them giving you this at an intern level, and then if you solve it, great. It's obviously better to solve it than to not solve it. But I believe you could even not get to a solution here, and if you come across as intelligent for an internship level, you might still be good. If you can't get this as a senior, that's a problem. Like, okay, question 2, you can see it's much, much bigger. And then I haven't even read question 3, but it wouldn't surprise me if it's even worse. But like for a senior, even if you haven't studied algorithms, you should be able to pretty much get question 1. All right, let me try and wrap this up. I appreciate the comments. So lengths of end minus start. Is it that, or is it end minus start minus 1? So end could be 5, 0, 1, 2, 3, 4, 5. So here's the 5th index. And it could be 1 to 5, 0, 1. Thank you so much. Yeah, the world's crazy, man. Social media is crazy. I don't want to age myself, but basically, like, when I was in middle school, like, none of this shit existed. So it's cool to be able to meet people through whatever, streaming or Twitter or whatever. So let's say I go 0 to 5. So is it going to be 4? Because 5 minus 1 would just give me 4. 1, 2, okay. 0, 1, 2, 3, 4, 5. So I'm on this one. And I'm going from here. So I got 1, 2, 3, 4, 5. So it's like n minus start plus 1. That would be inclusive. Inclusive length is end minus start plus 1. I don't know if I want to track the inclusive length. Do I want the inclusive length or the exclusive length? Yeah, I do. Yeah, I do want the inclusive length because the subarray is inclusive. If I have this position, you can't have this position. So I am going to track the inclusive length. So it's n minus start plus 1. And that will go with the pair start end. Now I'm setting it equal, which is going to replace, replace, replace. Really, I need to do an array of arrays, which is really annoying. I'm going to ignore that for now because like the rest of my implementation depends on this just being an array. But really, this needs to be an array of arrays. So now I'm returning start and end. So lengths. So now I have lengths. Have all these lengths, and we will say as lengths as array is equal to arrays or its object. Is it object or objects? Object dot keys. Yeah, object dot values is what I want. Object dot values of lengths. So that will be so that's going to give me an array of arrays where each interior pair is key value. That's what object.values does. And what I want to do is I want to find the biggest key, loop through lengths and return the start end pair. I want to find the smallest key and return the value. Okay, so let smallest length equal we'll initialize it to infinity. That way anything is going to be smaller. So let smallest length equal infinity. and let smallest key value pair equal an empty array. I don't know. Let me initialize it to null. Okay. So here I'll do for let I equal 0. I'll just do this whole for loop. I is less than lengths as array dot length I plus plus. Yeet yeet. Got him. Okay, so this is just your loop, right? This will be cur key is equal to lengths as array, and we'll say, and I could say cur length. The length is represented as a key, if that wasn't apparent, and this lengths hash map. And so that will be cur values. I'm going to destructure this into cur start, cur end, and that would be links array I. That'll be links array I0, and that'll be links array I1. Okay, so that's 0 and 1 in the inner array, key value, current key, and then the current start end. Smallest key value pair. Okay, so the question is that if it's just like a min-max operation. So if the smallest length, I'm going to change this to cur length. Key is the length in length hash map. Okay, so if cur length is less than smallest length, if cur length is less than smallest length, then now it is the smallest length. Okay, and now we need to update the smallest key value pair. I'm not gonna destructure it. I'm gonna call it cur pair. So that's actually an array, but we'll do smallest key value pair, and then we'll return smallest key value pair. Smallest key value pair should never be null. Okay, great. So I think we've completed the things. There's probably a bug in here somewhere. Is not a function. Get smallest subarray is not a function. Wow, that blows. Kind of thought it was when I wrote it. So why are you saying that it's not a function? So here I say function. Or it's return, it's an or. Okay, so this is like a compound error. And it's a type error. Is not a function, or its return value is not iterable. Actually, it is iterable. It's just TypeScript doesn't understand that it's iterable. All right, so check it out. So I'm returning smallest key value pair, which is initialized to null. So TypeScript is thinking, oh, this could be null, and you can't iterate null. The thing is, though, is like the type here should never be null. Like, it should always be, it should never be null. I'm going to say as any. Maybe that will make TypeScript happy. Nope. TypeScript's like, I don't believe you. It could still be null. Okay, fine. So here's get smallest subarray. And we're going to do smallest key value pair. And I'm going to tell it that it's an array. And then narrowest start, narrowest end equals smallest key value pair. That's called destructuring when I do that. If TypeScript is still mad, I'll just switch over to JavaScript. Smallest key value pair is not iterable. Literally, I'm telling you, it's an array of numbers. Dang, doesn't believe me. Okay, I'm going to copy this to my clipboard, and we're going to switch over to JavaScript. Bam. When I switch back, is it still there? That's good, because that'd be so racket if it just like obliterated my answer. Okay, now that we're in JavaScript, let's delete all the types. I didn't use that many types, so it's not that big of a problem. Okay. So it's still mad that it's not iterable. Let's go to this debugger. Click line to add a breakpoint. Okay. Let's break on these guys. Was the debugger useful? Let's see. Okay. Meta max one transaction is 4. Great, so far we're working. Smallest key value pair. Smallest key value pair is 4. Nope, that's a problem. Okay, so get smallest subarray is not working basically. Let me go back to TypeScript because it appears that it's not a TypeScript thing. It's like there's actually a problem. Get smallest subarray. So let me go right here. Well, I want my debugger. Oh, is there like, there's like not a TypeScript debugger? Oh, wow. There's not a TypeScript debugger. Are y'all seeing that? How come you switched to JavaScript? Good question. So I thought I was getting a type error. So TypeScript and JavaScript are the same. The difference is that TypeScript has types. So I kind of like TypeScript sometimes because it can guarantee me what my input is. Although if you see my stream from yesterday and the day before, Leetcode has given you wrong types in some cases. So I'm kind of sus on it. But basically, if I think my code will work and if I think the TypeScript compiler is making some incorrect assumptions, I can switch over to JavaScript. And the code still works, it doesn't have types enforced. So the question is, do I want types enforced or not? Like in a commercial project, usually the answer is yes, but if you're trying to script quickly, sometimes it can take more time to fix the types than to just like skip them. And now we have a second really good reason, because it looks like Leetcode does not have a TypeScript debugger. You see down here, the word debugger goes away. So I'm going to come over here, get smallest subarray, was it? Nope, we didn't get to the subarray. It was smallest key value pair, get smallest subarray. Yeah. The answer was coming back 4. which is like not what I expect at all. So I'm going to debug here, debug there, debug everywhere. You dig? Cool. I think that works. So let's go to this debugger and debug it. All right, so start of starts. So what's in starts? Starts is an array of 0, 0. That's weird. Do I believe that the optimal solution is 0, 4? 0, 1, 2, 3, 4. Oh, I'm pushing the... Yup. I'm not pushing the indices. Okay, so I did of. Of is going to be the value, like 0, but I really want the indices. So that would be in. This is why of loops are kind of tricky in JavaScript, because you can get like the wrong thing, basically. All right, yeah, stop the debugger. So I don't want const I of haystack. I want const I in haystack. Yeah, and you wouldn't run into this problem if you did the whole let 0 approach. Hopefully that was quick and easy. Let's debug it now. Start of starts. So, well, this time starts is just straight up empty. Yup, because my logic is bad. You know what? I'm going to not use this const I of haystack. We're going to do let I equals 0. I is less than haystack dot length I plus plus. Okay, so this will be const cur value equals haystack, the ith index of haystack. Okay, so it's not if I is start value, it's if cur value push I. So I need access to them both, so I should be using this sort of iterated for loop. Good news is we found the debug location really quickly, and it's not that complicated of a fix. Okay, so now I have starts 3 and 4, which are indices. So now I believe it. And this makes total sense, right? So the point of this function is to get the smallest subarray that will give me some some specific values that I mentioned. So start value is 0, end value is 4. And so it did give me starts where the value is 0. Boop, boop. Those are indexes 3 and 4. 0, 1, 2, 3. 0, 1, 2, 3, 4. Okay? So I am confident in starts and ends. So let's come down here, play over there. My red line is not proceeding. Okay, there it is. So now I have lengths. Lengths, there's length 4 and length 5. Did those work out correctly? Yes, they did. 4, 5, 6, 7 is, yeah. And so length says array, 4 and 7. Okay, this is a problem. This is a problem. Oh, because I just got values. I want like key value pairs. I think it's entries. Entries. Can I do, here's a console, right? Let's try entries. Debug that. Step over. So now I have lengths as array. Yeah, now I have the key up front. Great. But notice that the key is a string. Yeah, entries give, yeah. Thank you. Yeah, I got the method name mixed up. Whatever. That's why we debug. Yeah, so the only issue there is that I need the key to be I need the key to be a number. Lengths as array. So let me just go do one of these. Parse int. Okay, and now let's see if that key value pair down here is what I expect at that point. Smallest subarray, smallest key value pair 4, 7. That's what I like to see. Okay, great. Did subarrays work? Subarrays gave me 2 subarrays. It gave me the current and the prior. And then are we correct that the later can't exist? 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so there is no later. So subarrays worked. Get subarrays worked. Second subarray max profit. And third subarray max profit. So I ought to get 3. Maybe I should put that in its own variable, but it should be 3. It should be like 3 plus 4, basically. Output 7. Output 6. Buy on day 4 and sell on day 6. 1, 2, 3, 4. Okay. One, 2, 3, 4, 5, 6. Then buy on days. Yeah, okay. So, well, we're gonna wrap it up there. So the good news is that we got the implementation to do what I wanted it to do, and we were able to debug and resolve our bugs. But the bad news is that the solution is incorrect. Like the algorithm I implemented is not correct. Let's see. Oh, profit is 3, profit is 3. And what did I say? Profit is 7. Let's do that one more time. Nice, yeah, I play guitar. I also play drums. I'm actually a better drummer than I am guitar player. My wife is a good guitar player. Okay, yeah, so best second transaction is correct. It's the first transaction that's wrong. Why is the second transaction giving me 3? So over the range from 0 to 3, 0, 1, 2, 3. Over the range from 0 to 3, I can only make 2. Oh, get hype on this. If I fix that, I'll get a sum of 6, so they might sum to the same thing anyway. Get hype on this. I got 10 more minutes, by the way. Okay. So my hope is, although this is kind of like a long shot, but my hope is that even though their algorithm is different, I can still get to the same solution. So what I need to do, so my second transaction profit is wrong. Why does it think that I can earn 3 over the ranges from 0 to 3? So the second subarray so the third subarray max profit is 0, so I'm not worried about that. The second subarray max profit is 3. Max profit with one transaction, subarrays 1. So subarrays 1 is from 0 to 3. Oh, because I'm passing 0 to 3. What I should be passing is the price subarray from 0 to 3. Cool. So I want prices. Rubber ducking at its finest. Amen. Okay. I'm going to comment this instead of deleting it just so I don't forget where it went. So I should have the prices dot slice. The thing about slice always gets me because it doesn't literally take the indices, does it? It takes like the first index and then the number to follow, like the number of slots to follow. So I'm going to do subarrays 1, and I want to go from 0 to 3. So I do want to start at 0, and then the number to follow would be this. Let's break this line because it's getting ugly. So we're going to slice on the subarray 1 index, but then we're going to do the subarray end minus the subarray start to get the number of spaces to follow. Let's debug that. By the way, you know, to the point of what Frog Fan Account was saying earlier, even if you don't get an optimal solution, if you're debugging is like following good practices, you're going to show a lot of knowledge, right? So what I'm looking for now, second subarray max profit is 2, but I actually want to make sure that it wasn't correct by coincidence. I want to make sure that my inputs to there are correct. So this would be const second subarray. Right? I think it's just second subarray. I'll call it second prices. I don't think I'm using the term second subarray anywhere, but I don't want to pollute the namespace. Like, I don't want to run the risk that I'm accidentally using that somewhere. Second price. Okay, and then we're going to do const third price. So here's second price, and here is third price. Prices subarrays 2, and 2, 1 minus 2, 0. All right, and so then third price goes in here. Great. All right, so now let's debug it, but I really just want to run it. I'm pretty sure this debugging is going to work. So now second price, what is that? Second price is 335. That's exactly, nope, I don't want 335. I want it to say 3350. Okay. Good thing we did that. So I got to add 1. So it was correct by coincidence. Got to double check on that. 3350. Yep. Third price is not, we're not actually going to run into third price, are we? And so the output was 6. Okay, so we got a matching output. So let's actually run code results. Run code. Great, output was 6. Now they're going to fail me because I'm pretty sure, yeah, wrong answer. Output expected. So you could get 3 and 3. What's the best overall? Was the best overall is 4? So you could get 4 and then you could get 3. So I actually should have been able to solve for that. So my best overall was 2, 6. and then I should have been able to find 0, 3 within the remainder. All right, well, for another day. Hey, thanks for tuning in, and